Hi, what is up YouTube? Thank you for tuning in. Today we are going to unbox and review a DC to AC inverter from Reliable Electric. So let's get right into it. Alright, so this is the unit and it came with two sets of 20-inch wires. They already have lugs crimped onto them. And these are 16mm square wires or 6 American wire gauge. The user manual along with spare fuses. This unit is from YueQing Reliable Electric, as you can see here, and it's the 48 volt version. So if you have a 12 volt version, you want to pay attention to the wire gauge. They might send you the same wire set, which I believe would be a little too thin to carry all these amps. But for 48 volts, I think these would do just fine. So this is the 4000 watt version, 18 inches long and about 8 inches wide and 3.5 inches tall. So it's quite a bigger unit. So in the back we have two cooling fans along with the terminal block for the battery input, and these are 14mm nuts, a vent for cooling. We have one on each side, and to the front we have two LED indicators for the status of the unit. We have a smaller LED display to display the battery voltage, another bigger LED display for the AC voltage, a switch to turn the unit on and off. We have two AC units for regular application. I suggest you use this terminal block right here for your high current needs. For this terminal block, red is live, yellow is ground, and black is neutral. This is removable, so you can run the connections and then put it back. You want to avoid touching these if the unit is on. 48 volts unit, and you can run 42 volts all the way up to 60 volts. When your battery reaches 42 volts, it's going to cut off to protect your battery. And when it goes above 60 volts, it's going to cut off also to protect your inverter, which is great. That's a wide voltage range. So for this test, I have this battery that I already have XT60 connectors hooked up to. So I'm just going to manage to use this right here and connect it to a log just for the test, because this battery isn't exactly set up for any form of high power application. I have this BMS wire with an on and off switch. BMS is on. I can connect it wirelessly to this tablet. Just like that, I'm connected, and I can switch to voltages. I can set up settings, cut off voltages. And I can also wirelessly store balancing function for each battery, monitor current draw, and other functionalities. Here I can see the voltage on each cell. It's a little out of balance. That's why the automatic balancer kicked in. I found this to be very slow, by the way, but I don't mind. So why don't we go ahead and crimp some wires and get this tested. This green pattern right here means that it has a anti-spark functionality. Basically, this is a resistor midway. So as you connect it, it connects a resistor to the unit for a split second before connecting the full voltage directly onto it. So the capacitors get charged slower because they get connected in series with a resistor, which prevents it from sparking. And as you can see, no spark. Alright, so we are connected. Thin wiring, but we're not connecting any appliances to it yet, so we should be fine. Alright, looks good. The fan is already on for some reason. Alright, so it turned back off. We have 49.5 volts and the output is 124 volts AC. Alright, so looks good so far. So to get this set up and tested, I have this multifunction energy meter and tester. It has a display and shows energy consumption information. More on that in a second. This is what it looks like. I also have a circuit breaker, very useful for our setup. I have ferrules to ensure good connection onto the sockets, crimp tool for the ferrules, lugs, crimper for the lugs, AC and DC multimeters, extension with a built-in energy meter. It's very important to use the right tools for this because we are dealing with high voltage. Alright, so we have a second wire to add in parallel. Just like this. Connect the second XT90 connector. Alright, so now we can carry twice as much current. As you can see, this goes up slowly. 124 volts. The second one, 124. The terminal block, 124. So from live to ground, we have half the voltage, 66.6, and from neutral to ground we have the other half, 56.6. This is the standby current draw, 400 milliamps. Now we want to go ahead and wire this using the circuit breaker and the energy tester / meter. Alright, so we are set up. Let me walk you through my temporary setup, because obviously this isn't adequate for permanent use. So I have my wires connected to this terminal block, and then the 120 volts lead goes to the circuit breaker right here, and then out the circuit breaker I connected a parallel lead which is connected to the power meter slash tester. And according to the diagram, you have to parallel from your breaker into the tester, and then the positive lead only goes through this hole for the metering and goes out the other way and then back to my outlets. So the negative just came straight from the circuit breaker onto the outlets, and then I have two outlets connected in parallel. Alright, so let's go ahead and turn on the inverter. So up to 124 volts. Alright, next step, we're gonna go ahead and turn on the breaker. And as you can see, the energy meter displays the power in watts, consumption in watt hour, voltage, the frequency, the current, and the power factor. The reading is very accurate, and as you can see now we have 124 volts on the voltmeter. Alright, now we can go ahead and hook up a couple of appliances and get it to show the power readings. I have this extender connected also. It has a built-in watt meter, power factor, frequency, current, and voltage. That's pretty good. Alright, so we have the fan connected. Now we're gonna go ahead and turn it on. This is speed number 1, and here it shows about 101 watts, and this one shows 95.3 watts. Wonder which one is more accurate. I would go with this one all day long. Alright, so let's switch to, oh, this one dropped to 99. Alright, it's pretty close. I guess this one is self-adjusting maybe, but that was speed number 1. Let's crank it up to speed number 2. With speed number 2, we're up to 105 watts here and about 98 watts right here. Alright, so let's go to speed number 3. 107, 102. Alright, so next step is the space heater. Let's go ahead and turn that on. The highest heat possible, and then we turn on the fan. It gets hot very fast, and here we have 1700, 1560 something watts. That thing is really power hungry. Alright, so here we have 1433, 1430. Wow. So let's go with 1420. Next step, we have the soldering iron. Let's turn it on. Then we're gonna crank that all the way up 896 degrees. Watch that heat up really fast. Alright, while it is heating up, we have this. Okay, it's going down as the tip gets hotter. Let's wait until it settles. Alright, we are at maximum heat, and this reads. Alright, but let's go with about 30 average. I was also supposed to show you the DC current draw. Oh, I still have it set to AC. It's meant to be DC. Alright, so here we have 1.5 amps because it's variable, and the voltage drop isn't so bad, 48.8. Next is the iron. Alright, we have a big drop to 46.2, and this is 1270 something watts. Whoa. Air conditioning unit. 700 and change. Alright, so we have 740, 750 watts. Not so much of a drop. And we have an overload here. Let's switch this. 18 amps being drawn from the battery. Alright. It's still good, that's nothing. 18, 19 amps, 20 amps. Alright. I think this is the highest power. Fan speed. Alright, now this is the highest. Have 22 amps from the battery. Not so much of a draw. 46.2, 950 watts. And the fan kicked in. It's not too loud, and it doesn't last for too long also, which is nice. Here we have computed all the powers, as you can see here, and the total comes out to 3790, almost 4000 watts. So we're gonna stay right here and not risk an overload or anything of that sort. We have all 6 devices connected. First with this heater. This is all the way up to 1800 watts, going down, and the drop insane. The iron, and we up to 2600 watts, going down, and the fan kicks in. The fan, it's hot, high. Oopsie, it shut down. Yes, we have an error, 46 volts, and it shut off the output. So let's turn it off. I wasn't paying attention to the voltage drop. I wonder if it reached the 42 volts mark and shut off, or it was the output being too high. Alright, so we're gonna go ahead and run the test one more time. Alright, we have 30, we went up to 30 something, 42.4, 42.3, 44, 44.2, and we at 1476. All right. What is the cause? Why don't we turn on the fan? Drop to 43.9. Why don't we turn on air purifier? 43.8. Why don't we turn on 1662? We are 43. Everything is on, as you can see. Okay, 43, back to 43. We are 1600. That is very hot here. Very hot here. On. Everything is on. We are at 1600 watts. 43 volts. Alright. Okay, we're back to shut off. This is rated at 4,000 watts and 8,000 watts surge. Alright, so I added a battery just to see if it's the drop. Alright. No worries about feeding because they are at the same voltage. So they're both connected in parallel. All right. All right. 35, 33, 32, 31, 29, 29. 1600, 44.6. Alright, the battery is getting warm a little bit. So I'm gonna go ahead and add an appliance. Alright, moment of truth. What is better than a microwave to test this thing? Fan on. Everything is on. 1500. Alright. This on. 36. 31, 32. then back down to 1700, 1700, 1600, and then the microwave in 30, drop to 43 volts. So I'm gonna let it run for a little bit. This shows that it does try to hold up, but the voltage drop to 42 is not gonna help it, but it is running. The battery even warmer, way warmer. This one is cold. These are multi-cell 42A batteries. They're powerful. This is getting hot now, but everything is maintaining with a flimsy setup. I think that if I had an adequate setup, I would be able to run this fully at 4,000 watts because it's holding. Voltage drop 41, 40.9, then back up to 41.8, but it's holding at 30, so I bet you that I could run it at 4,000 watt if I had the right setup. It's just the battery that is not gonna have it because it's dropping way too much. The microwave is done cooking. Alright, so let's go back to 2 minutes, and that did it. The voltage dropped and it shut off. Battery hot, this one cold as ice. Alright, I think that's gonna do it for this test. I think a high voltage battery would be better. This is a 50 volt setup, but it was down to 49 volts when I connected it. So it quickly dropped to 42, which is cutoff voltage. Alright, so in case you wanted to know what's on the inside, you have 2 big blocks of heat sinks. Could do something good to the cooling. Check out these coils, these inductors. And here you have your fuses. I just turned it off. I avoid touching potentially high terminals. These are the 20 volt fuses that they give you the spare parts for. 6 transformers, 48 volts. And check out these capacitors. A temperature sensor connected to the bigger heatsink block. I think it's also getting hotter than everything else in the system. Check out these FETs. The fans on the other side, all along. So I was just looking around and look what I found. A bad capacitor. This blew up right here. For some reason, the unit still functions correctly. There are a couple of them here, still intact, except for this guy. Yeah, I wouldn't have figured this out if I didn't open it. So I will get a replacement for this and swap it out. And just like that, this has been replaced. But yeah, let me know in the comments what you think. Till then, I will see you on my next video.